Welcome back. Today we're going to jump into section 1.7, which covers midpoint and distance in the coordinate plane. We're going to focus mainly on the midpoint today. It starts off pretty easy, and then it does get significantly more challenging towards the end. So first up, what we're going to look at is there's two different types of problems where the midpoint will occur. We have midpoint on a number line right here, and then we have midpoint on the coordinate plane. So a number line is, the number lines you worked on in elementary and middle school. And then the coordinate plane would be middle school, high school midpoints, where you're dealing with lines in a two-dimensional area. So first, we're going to look at midpoint on the number line, which is pretty basic. It's essentially finding the middle of 2 points, or the middle of a line segment, except we're working with a number line right now. It's also another way to find it is by calculating the average of the two numbers on the number line, or the mean, which is something you studied in middle school and probably a little bit in algebra. So in the diagram right here, we have points A and points B. They're labeled as coordinate A, coordinate little b, and then M here is the midpoint. So if M is the midpoint, then that means the segment from A to M is congruent to the segment M to B. And that's why these little tick marks are here. So that's indicating that M kind of bisects this segment AB right here. To calculate the midpoint M, the value of the midpoint M, we find the average of A and B right here. And if you remember, average or mean, we add the two values together, A plus B, and divide by 2. And in this case, we're dividing by 2 because we're finding the middle of 2 points. And in some cases, when you're finding average, you divide by the total number of items in the group. And in this case, we're only working with 2 points. So this is your midpoint formula for a number line. And then for a coordinate plane, it gets a little bit more complicated. Some lines are horizontal and vertical in the number line, or in the two-dimensional coordinate plane. And finding midpoints of those are pretty easy. It's essentially the same method right here. But most of the lines we're going to work with are lines that have a slope that does not equal 0, or a slope that's not undefined. Basically, in layperson's terms, it would be a slanted line, basically. So we have 2 points, A and B, and this is the midpoint right here. It's, it splits the segment right in half. So the distance from A to M is congruent to the distance from M to B, and you really can't eyeball it in a two-dimensional coordinate system. You can approximate it, but we're not approximating at this point. So the way it works is we're going to work with a formula. The formula can sometimes be confusing, but we have point A here in red, and we're labeling the X and Y coordinate as X sub 1, Y sub 1. This little 1 here is just identifying that it's the first point we're working with. And then over here for point B, we're labeling point B X sub 2, Y sub 2. And again, the 2 is here just as labeling it as the second point. So here's A, here's B. The coordinates for A are right here, X sub 1, Y sub 1. The coordinates for B are X sub 2, Y sub 2. So the formula is it's two formulas in one. You have a formula for the X coordinate of the midpoint here, and then we have a formula for the Y coordinate of the midpoint. So when you're working with just the X coordinate of the midpoint, you're really only working with the X coordinates of point A and B, X sub 1, X sub 2. So this coordinate here and this coordinate here. You add them up, and then you divide by 2. So you're finding the average of those two coordinates. X coordinates, excuse me. And then for the Y coordinate of the midpoint, same idea, except you're finding the average of the Y coordinates for both points, Y sub 1, Y sub 2. So we're going to add those 2 and divide by 2 here. I'm just labeling these points here for B and points here for A, just to give you a visual to make sense of this. And that's essentially what the midpoint is. And then we move into an example. So first question starts on the number line, finding the midpoint. Segment AB has endpoints at -4 and 9, what is the coordinate of its midpoint? So in some cases, students will count in, or they count an equal number of points in from A and B until they find the middle. That can be done in some cases, but not all cases. So you have to be careful with that. So we want to try to use algebra since you guys just finished the algebra course. So we're going to let point A be equal to -4. So the name of point A, or the coordinate for point A, is -4. The coordinate for point B is 9. And what we're just going to do is find the average between -4 and 9. You're finding the mean, basically. So to get started here, I'm going to take the average of those two values. So -4 plus 9 divided by 2. -4 plus 9 is 5. 5 divided by 2 is not an integer number. It's a decimal or a fraction. So 5/2 is an acceptable answer in this case. However, most of you are probably going to throw this in a calculator, which is acceptable. So your midpoint in this case, when you divide 5 by 2, is going to leave you with 2.5, or some of you will convert it to a mixed number and call it 2.5. And that's it. It's very, very simple at this point. Then we get down into the next question here, where we're looking at how to find the midpoint of 2 points on the coordinate plane here. Okay, so the 2 points we have are E, that's 7, 5, and F, 2, -4. So the first thing what you want to do is kind of establish which point you want your first point to do. So when I look at a graph, I always recommend that students read the graph left to right, just like you read a book. So I always label the leftmost point here as my first point and my rightmost point as my second point. So the coordinates 2, -4 are now labeled as x1 for the first point and y1 for the first point. And then up here for the second point, I'm going to label 7 as x2 and 5 as y2. And remember, we're basically creating two separate formulas to find the midpoint, because the midpoint is made up of two numerical values. So this is one part of the formula for the x coordinate of the midpoint. This is my second. Again, you're adding the x coordinates together, divide by 2. Then you add the y coordinates together, divide by 2, and you have your midpoint. It's a pretty basic calculation. So to get started here, my x1 value is 2, and my x2 value is up here at 7. 2 plus 7 divided by 2 is the first part of my formula, and then I'm going to fill out the second formula, y1 plus y2. So my y1 value over here is -4. My y2 value over here is 5. So -4 plus 5 divided by 2. And that's that part of the formula, fill it out. And now we just do our calculation, right? So on my x coordinate, 2 plus 7 equals 9 divided by 2. Here we are. -4 plus 5 equals +1 divided by 2 over here. This is an acceptable answer. 9/2, 1/2 works perfectly. It's an exact value. Again, many of you will throw this into a calculator and you'll convert 9/2 here to 4.5, and then you'll convert 1/2 here to 0.5. And there's your midpoint. So make sure your midpoint is in an ordered pair, right? That's parentheses on both sides with a comma in the middle. Make sure your x coordinate comes first, your y coordinate comes second. And that's essentially it. It's a simple calculation. You just need to know your formula. I will also say, while we're on this, I just happens to label this point F here as x1, y1, and this point E right here as x2, y2. Please understand that you can reverse it and you can call this x1, y1, and down here you can call this point x2, y2, and then populate the formula. You will get the exact same value no matter how you look at it. So the order in which you set up your midpoint piece from this situation doesn't really matter in the sense of labeling your points here. Okay, next example. JK has midpoints at -12 and 4 on a number line. That's critical. What is the coordinate of its midpoint? So that's kind of like the first example we just did. So I highly suggest you give yourself diagrams. Geometry is very visual. The diagrams kind of unlock a lot of information for you. So on my diagram, I first set up a number line, and then I put a scale on it. So I put 0 in the middle, and then I labeled a 12, positive 12 over here on the right, negative 12 over here on the left. And then I also kind of established two other values on my number line, positive 4 and negative 4. If you wanted to, you could go through and make tick marks and scale this 1, 2, 3, 4, 5, 6, all the way up to 12, and then negative 1, 2, 3, 4, 5, negative 6, and all the way to negative 12. But this works because the visual is just helping you make sense of, how to visualize the midpoint. So we're really working with negative 12 and positive 4. So right here, negative 12 is the point I need to work with, and over here on the right, 4 is the other point I need to work with. And we just find the mean of these two values, or the average. So that's going to be negative 12 plus 4 divided by 2. You could also reverse this, and you could do 4 plus negative 12 divided by 2, and you'll get the same value. So negative 12 plus 4 is negative 8, divided by 2 gives me negative 4. So our midpoint for this example is negative 4. Again, pretty basic example, shouldn't be hard for many of you. And then the next question we have back up here for part B. What is the midpoint of segment RS with endpoints 5, negative 10 and and point S 3, 6. This is a situation where we're on a coordinate plane, X and Y axis here. So we need to use the midpoint formula, the second midpoint formula we looked at for the coordinate plane. So down here, if it's comfortable for you to make a sketch, go for it. In this case, because you have a formula to work with right away, I do think this sketch is a little unnecessary. So right now I have point R and point S. I'm labeling point R here as X sub 1, Y sub 1. Remember the little ones here are just establishing that's my first point. And then for point S, I have X sub 2, Y sub 2. And again, little subscript of 2 is just identifying my second point. Over here, I have my midpoint formula. Make sure you understand that you're adding the X coordinates and dividing by 2. And then over here, you're adding the Y coordinates and dividing by 2. So I'll start 5 for my X sub 1 plus 3 for my X sub, for my X sub 2 divided by 2. And then for the Y coordinate of the midpoint, it's Y sub 1 for negative 10 plus Y sub 2 for 6. Then I divide that by 2. Continue simplifying. 5 plus 3 is 8, and 8 divided by 2 is 4 here. And over here on the right, negative 10 plus 6 is negative 4. And negative 4 divided by 2 is a negative 2, giving me this is the midpoint of that segment RS there. Again, if you reverse the points and you labeled this as X sub 1, Y sub 1, and this is X sub 2, Y sub 2, fill out the formula, you still get the exact same answer here.